All right, this is number 2 on the video quiz. A coffee machine dispenses coffee into cups. A customer is supposed to get 10 ounces of coffee, but the amount varies slightly from cup to cup. Here are the amounts measured in a random sample of 20 cups. So N equals 20. Test to determine whether or not the machine is underfilling cups. Because it says test, I'm going to believe that I'm working with a hypothesis test. One thing I noticed is they did not give me an alpha level or the level of significance. So since they didn't, we're AP stats, I'm going to assign an alpha level of 0.05. Also, I don't have a mean, I don't have a standard deviation of the sample, and all I have is sample data. So I need to take a moment and enter that sample data into the calculator, and I went stat edit and entered it all in. So I did that pretty rapidly, got that in. Then second quit, stat calc, one variable statistics. And hopefully you're getting an X bar, and this is what you should use to check yourself, an X bar of 9.845. A standard deviation of the sample, make sure you're using the S of X. And we're just going to take it to 4 different places. So S is 0.1986. And because this is a we're using a sample standard deviation, we're using a T. And so our degrees of freedom in this case are going to be 19, which is 20 minus 1. So we need to write our null and alternative hypothesis. And generally speaking, this might not be the most tiresome part, but this is the most difficult part for most students. Well, the null is the original claim. Well, in a jury trial, we assume that they're innocent. So we assume the status quo is the case. We assume that their claim is correct. So we assume that they're actually getting 10 ounces of coffee. All right, the alternative, we're still looking for a mu. This is still going to be 10. And now the question is underfilling. All right, so that means we're going to be less than 10 ounces. And couple cautions right here. This will never be an X bar, all right? And you will never use your sample statistic, all right? So never use your sample mean over here. It'll always be another number. So if they give you a sample mean, you know that doesn't go here, all right? And this always has to be the Greek letter mu. And I know mine looks like an M, but it needs to be the Greek letter mu. If you use X bar here, you're going to lose 25% of your score right off the bat. And honestly, College Board gets really picky on that and starts looking at points for other things. So let mu equal what are we measuring? Well, we're measuring the true amount of coffee per cup. So the true population mean amount of coffee. Need my coffee in the morning. Now, I'm not a coffee drinker myself, but for those who are. Conditions. The first condition is it needs to be a random sample. Fortunately, they told us it was up here. They said, hey, it's a random sample. And this is just given. 2, the next thing that they ask is the next thing we need to check is whether or not it's less than, our sample is less than 10% of the population. So our sample was size 20, 20 divided by 0.1 equals 200. And I'm going to say reasonable to assume Starbucks sells more than 200 cups. You're like, you didn't say Starbucks. I know, but I just made something up. 200 cups. So our sample is less than 10% of the population. The third condition. Third condition is normality. And we can check normality. If they tell us it's normal, we can write normal and given. They didn't tell us that. If our sample is size 30 or larger, we can say it's normal by central limit theorem. In this case, our sample is size 20. So we don't know that. So I am going to have to draw a box plot. And when I do that, I've already entered the data, entered my stat edit, so I've already done that. Go to y equals, make sure that that's clear. You don't want anything there, otherwise it'll mess things up. So I clear the second quit, I get to the clear screen. I'm going to press second, followed by stat plot. Press enter. I'm going to arrow over to the left to make sure it's on, and then press enter again. Then I'm going to drop down and arrow to the right until I get to the box plot that shows outliers or has the dots. Press enter, drop down. My data was stored in L1, so second 1. And at that point, I can just do a zoom, followed by the number 9, and I get a box plot that looks like that. And we'll talk about that in a second. The very first thing I do is I just try to sketch this thing out kind of the way it looks. So sketching this out the way it looks, something like this. And I know it's not truly precise. Then I use my trace feature, and I get a minimum of 9.5. The next value is 9.7. The median value is 9.9. This is the 10 ounces. And now this is how much we were supposed to be selling, is 10 ounces. So there, it looks like there's a little bit of evidence to say that they're underfilling. The question is there enough evidence? Could this have happened by random chance alone? All right. And so this is ounces of coffee. And right away, I look at this and I go, you know what? No outliers. But is it reasonably symmetric? It's somewhat symmetric. It's not that bad. So the data or the box plot is reasonably symmetric with no outliers. And it's really important that you include the no outliers. If you have outliers on your data, please go back and rerun the thing. You probably made a mistake. The distribution appears to be not normal, because we're not going to make that claim, but we're going to say it's approximately normal. We're giving ourselves a little bit of an out. Okay. Also, the more normal it is, the easier it is to justify running this. So even if it weren't perfect, if it's close, it's going to be good enough. So T equals X bar minus mu S divided by square root of N. My image, my drawing is going to look something like this. The claim is 10 ounces. We actually get some evidence, not a whole lot, but we're a little bit below that 10 ounces, 9.845. And we were worrying about an underfilling because we had a less than on our alternative statement, and this is for our X bar. And so we want the probability that X bar is less than 9.845, and that equals the probability that T is less than 9.845 minus 10 over my sample standard deviation 0.1986 divided by the square root of 20. And what that gives me, so I go stat test, I'm going to go to number 2, t-test. Now I actually have data this time, so I'm going to want the data highlighted. The mean claim that we got from our null hypothesis 10. My data is in L1, so second 1. We have the less than, we want the less than because that's the way we wrote our alternative, calculate, and we get the probability that T is less than negative 3.490 equals 0.198, excuse me, equals, that's the wrong probability, 0.0012. So this right here is my p-value. I'll put that back up on the screen so you can see where I got that from. So here's my negative 3.49 for my t statistic, and that probability of getting a t statistic like that is 0.0012, and that's my p-value. So they didn't give me an alpha. We said we'd use an alpha of 0.05, and so we have p-value, we have alpha, 0.0012. You're in the middle of a test and you're rushing. Make these the same length. I know you know how to do decimals, but this needs to be 4 places. Well, 500 is definitely greater than 12, so my p-value is less than alpha. So our decision is to reject the null. That's our decision. So let's write this out, our conclusion out. Our p-value is 0.0012. What did we decide? We reject the null. There is sufficient evidence at alpha equal 0.05 to suggest that the true population mean ounces of coffee is, what was our alternative? Less than 10 ounces. So what we just said is we took a sample of 20. Based on our sample of 20, there's less than a 1% chance that we'd get a test statistic as extreme as 9.845 or more extreme or less, given that the null is true. So that's pretty rare. So we're totally not buying into that. We just figure, you know what? Yeah, it could happen, but it's so small. It's less than 1%. Consequently, we don't believe it. So let's define our p-value in context. So in this case, there is a 0.12% chance of getting a sample test mean of 9.845 or less given that the null of 10 ounces is true. All right, there's a 12%, less than a 12% chance. There's a 0.12% chance of getting a sample test mean of 9.845 or less, given that the null of 10 ounces is true. All right, so that concludes that one. And we have one more video to come.